if we were told this, take the first derivative at that point. You could do multiple things. You could graph this on a graphing calculator and go stat calc 6 and then go to pi, see what that answer is, and see if it matches any of those. Okay. Or we could do it the right way by what's first derivative of sine? So it is the cosine of 2x minus pi over 3 times the first derivative of the inside, which is 2. Okay. And it says at pi, so we throw a pi in there. So it's 2 times the cosine of 2 pi minus pi over 3. 2 pi minus pi over 3 is like 5 pi over 3, correct? So it's 2 times the cosine of 5 pi over 3. 5 pi over 3, the cosine is 1/2. 2 times 1/2 is 1. There we go. Now, like I said, if you did it on your graphing calculator, I think it would also say 1. Cosine is the x value, so it should be positive. So, whoop. No, thank you. So, if I took the sine of 2x minus alpha y equals fraction pi, whoops, second that pi over 3 parenthesis, and then I graph that. I need to go zoom trig here. Zoom trig is 7. Okay, there's a graph of that. And if I go second calc, stat calc 6 at second pi, enter, it's really super close to 1, which is 1. Okay, so just a way to check your answer using the graphing calculator. All right. What rule would we use here? Chain rule. So it's 3 cosine of x cubed to the 1/2 power. Okay? So it's 1/2 3 cosine of x cubed to the negative 1/2 times the first derivative of the inside. The inside of that is this part here, so it's 9 cosine of x squared times the first derivative of the inside of that, which is negative sine of x. Okay? So with the chain rule, if it's complicated, it's like John said, chain. So, yeah, because you have power on a trig function. So then you have to keep going until you take derivatives of the insides. Okay, so this goes to the denominator. So 2 square root of 3 cosine cubed of x is in the denominator. This is all in the numerator. So negative 9 sine of x cosine squared of x is in the numerator, which is b, right? Yeah. Okay. Rule for this one. I'd do this by the power rule. I'd rewrite it like that and do the power rule. Much easier than trying to do the quotient rule. Quotient rule, you're probably going to make a sign error somewhere along the line. Okay? So the first derivative of this is negative 12x to the negative third. The second derivative of this is positive 36x to the negative fourth. Okay? Easier to do the power rule than to do the quotient rule. Whoa, that was the same one. Okay, this one. It's basically saying do the chain rule to this. Okay? Because it's h of x is the inner function, f is the outer function. So to do the chain rule to this, it's f of h of x times f of h of f prime of h of x times h prime of x. Chain rule. Okay? So at 2, what's h of 2? Negative 1. So you're taking the first derivative of f at negative 1, and then the first derivative of h at 2. Okay? The first derivative of f at negative 1 is negative 5. The first derivative of h at 2 is 6. You get negative 30. Okay? Just a reminder of how to work those charts. Yep, I'll stop for a second. Are they M&Ms or are they Skittles? I love them. Okay, thank you. I missed what Jackson said. But okay, arctan of 2x at negative 2. Find the derivative of that. Arctangent. Remember that's du over 1 plus u squared. Memorize that one. Memorize the arc sine one. The arc cosine is easy if you remember the arc sine because it's just the negative of it. Okay? So, what's the first derivative? What's du here? 2 over 1 plus 2x squared, or 2 over 1 plus 4x squared. Then you're going to put a negative 2 in for the x. Negative 2 squared is 4. 4 times 4 is 16. 16 plus 1 is 17. So it's 2/17. Inverse function. You have an f and a g. So you just got to think opposite of this number, the other number from this number. And it's 1 over that. So it's 1 over the first derivative of f at the other number, which is 5. Okay? You know how the chart works now. So it's 1 over a negative 1/2, which is negative 2. You'll see on Monday. Because I don't remember off the top of my head if I have a chart one or if I have an inverse one. You got to find the inverse. It's one or the other. What? The opposite letter. Yeah. Well, you do the first derivative of f at 5. The first derivative of f at 5 is negative 1/2. And then 1 over negative 1/2 is negative 2. Okay, this is the disguised derivative thing. So 7e to the 4 plus h is 7e to the x. You replace this with an x. You take the derivative of this, because this is f of x. So the first derivative of that is 7e to the x, and then you replace the 4. So on the disguised derivatives, whatever this part is, you put an x in there, you do the first derivative of it then, and then you replace back the number that's in there. Okay, second derivative of that. First derivative, 3x squared plus 2y dy dx equals 0. You solve for dy dx. So 2y dy dx equals negative 3x squared. And divide by 2y. Nope. You got to take the second derivative. It says, what's the second derivative? So now we do the quotient rule. d2y over dx squared, second derivative, is 2y times the first derivative of the top, which is 6x, minus 3x squared times the first derivative of the bottom, 2, over 2y quantity squared. Now, Jackson, we can put in the numbers, 2 and 4. So it's 2 times 4 times 6 times 2 minus 3 times 2 squared times 2 over 2 times 4, and that is squared. So 8 times 12 is 96, minus 2 squared is 4, times 3 is 12, times 2 is 24, over 8 squared is 64. 96 minus 24 is 72 over 64. They're both divisible by 8, so it's 9/8. Now, what I would definitely do on this one, no, that would be really hard. I don't know if the graphing calculator can do it very easily. Well, because what you'd have to do is move the x squared over, so y squared equals x cubed over 24 minus x cubed, and then take the square root of each side. So you need both the positive and the negative of that. And then you take the derivative of it, but then you have to take the derivative again, and I don't know if the graphing calculator takes the second derivative. I don't think so. Oh, crap. Forgot that. You're so good. When we take the derivative of that, is 2 dy dx. Dang it. Forgot that. So, and then the dy dx is, yeah, so this is 2 dy dx. And then this would be 3 times 2 squared over 2 times 4. Woo! Thanks for saving us. So it's 96 minus, this is 12 over 8. This part is 12 over 8. And this part is 24. So that breaks down into 36, which is 60 over 64, which is 15/16. Yeah, hopefully that's right. But yeah, I screwed that one up. Chain rule. What's the inner, what's the outer? Well, the inner is obviously square root of x, and the outer is log of x. We know the chain rule good enough. We can handle that. Which one is this? Quotient chain. You guys are good. Because the cosecant of 3x has to do the chain rule to it. So first derivative. This is implicit differentiation, and you need to know implicit differentiation as we go through here. So, what is it? Well, it would be 2x, because we do the product rule of this, 2x times first derivative of y, which is dy dx, plus y times the first derivative of 2x, which is 2, minus, or plus 3x squared, don't need no dy dx there, minus 6y. Oh, since we took a derivative with respect to y, we need the dy dx equals 0. Nope, the y wouldn't go away because there's still 1 there, because we do the power rule. So it's 2 times 3, and then drop the power by 1. Okay, so 2x minus 6y have the dy dx on it. The other two things go to the other side, so negative 3x squared minus 2y goes to the other side. And then we divide by 2x minus 6y. So, Oh, I see what happened. They pulled the negative 1 out on the top. I was going, none of these match, but this one does. Because if you pull out a negative 1 on the top and put it out front, that one matches. Okay, we good? Jacob tried to do this. He said we should use the product rule. Should we use the product rule? Yep, absolutely. Then he stated the product rule in step 2. Is that the right product rule? Not at all. Because it's you don't just take the derivative of both of them and multiply together. So you didn't state the correct product rule. How would you rewrite this using the power rule? You'd have to do what? Distribute. Choice B. Distribute. First derivative of this. What rule? Chain rule. Thanks, John. Sine of x to the 7th power is 7 sine of x to the 6th power times first derivative of the inside, which is cosine of x. So it's 7 sine to the 6th of x cosine of x. You guys are going, hey, maybe I'm a little smarter than I thought. I kind of remember a lot of this, right? And that's it. That's the basics.